This is chapter 15, question number 19. And 19 states, a 50-gram object connected to a spring with a force constant of 35 newtons per meter oscillates on a horizontal frictionless surface with an amplitude of 4 centimeters. Find A, the total energy of the system, B, the speed of the object with a position of 1 centimeter, C, the kinetic energy, and D, the potential energy with the position of 3 centimeters. So first we want to list our givens. We're given that the mass of the object is 50 grams, the force of the spring is 35 newtons per meter, the amplitude of the spring is 4 centimeters, and the positions 1 and 3 will be used in parts A and C. So first we have to define what we're going to solve for, and so our finds are the total energy of the system E, the speed of the object V, the kinetic energy Ke, and the potential energy Pe. So in step 1 we're going to solve for the total energy E. Now we need an equation for that, and that equation will be E equals 1/2 Ka squared, where K is the spring constant and A is the amplitude. Now if we plug in, since we have K and A, if we plug those into our equation, 4 times 10 to the negative 2 is just the same as saying 4 centimeters. So we plug those in and we get 28 millijoules. Part B, we're solving for the velocity. And so the absolute velocity is equal to omega square root of a squared minus x squared, a being the amplitude and x being the position. Or it's also equal to the square root of k over m, which we will use this formula because we have k and we have m. So if we plug in k and m, a and x, we get something that will look like this, with the force constant above the mass, and the mass will be converted to kilograms, that's why it's 10 to the negative 3. And then plugging in the amplitude and the position 1, we should get a 1.02 meters per second as our velocity. Part C, we're solving for the kinetic energy, and the kinetic energy is 1/2 mv squared is equal to 1/2 Ka squared minus 1/2 Kx squared. Now we have Ka squared and Kx squared, so we will plug those in, and another way to convert that, since K is used in each, is to separate it from the variable. So it'll be 1/2 the force constant and then amplitude minus the x value, which the x value in this case is 3 centimeters. And now if we plug those in, get our numbers, we should get 12.2 millijoules. And finally, with potential energy is 1/2 Kx squared equals E minus 1/2 mv squared. Now we have all these numbers, we're going to plug them in, and if we plug them in right, we'll get 15.8 millijoules.